and appreciate you all being here for another Electric Culture of Safety ECOS. We now have over 10,000 members, so we've increased quite a bit since this flyer was placed out. We also have our website now, electriccultureofsafety.com. It is live. It's under construction, so just bear with us. It should be looking pretty good next couple weeks. Maybe 1st of December, look really sharp. We're going to have some blogs on there, a lot of references, things that you guys can use for your safety resources. And Bulwark is a part of ECOS. You can see their logo on the partnership logos right there with the rest of the partners. And you can see Bulwark here. They do a great job. Great people to get to know. And we're proud to have them represent ECOS and be participants of what we're doing, creating a nationwide line team. So tomorrow we'll have Mr. Jerry Havens with T&D Power Skills. So stay tuned for that. We have 2 speakers every single month doing these lineman safety national webinars every single month. And we are booked up until 2025 with speakers already in line for you all. So enjoy and listen in.
Well, good morning, good afternoon. Welcome to our webinar. And Brent, thank you for a great introduction. As Brent said, we're we're on that ground floor when ECOS first kicked off, because really my role within Bulwark is not sales. I get to talk primarily on the proper selection, use, care, and maintenance of flame-resistant arc-rated clothing for short-duration thermal hazards. So with that, if you do go onto the website and you do look at some of our archived footage and some of the archived webinars, last year we talked about the proper selection, use, care, and maintenance of flame-resistant and arc-rated clothing. And when Brent asked me to speak this year, one of the things that came to mind is there's still a lot of myths and misconceptions about this PPE that's out there. So I wanted to kind of go through kind of like the top 10. These are by no means all inclusive. You may have some questions that come up at your facilities, come up within your company that you would like to have answered. The cool thing is my my email will be on the last slide. Take a screenshot of that. Feel free to contact me and we can help you out. So meet your speaker. So again, Senior Technical Training Manager for Bulwark Protective Apparel, long-winded way of saying, I don't sell nothing. I've been doing this for 25 plus years now in a variety of positions, all the way from the fabric side, through the sales side, and now today really in the training side. I like to tell folks, if you've ever heard me speak before, I got started back when you could get any style, any color of navy blue Nomex coverall you wanted, because that's really all that was in the marketplace at that time. And our utilities weren't even really utilizing flame-resistant clothing at that time as PPE. So my territory, North America, Middle East, and Europe. I've done this presentation and others in about 7 different countries. I've been through almost every single state in the US and almost every province in Canada. So I've got to do this for a lot of folks over the years. So with that being said, just real briefly, this presentation, understand, is for informational purposes only. The legalese and all this stuff is customers of Bulwark Protection are solely responsible for selecting the appropriate garments and personal protective equipment for their employees. Employers must ensure wearers use, care, and maintain their garments and personal protective equipment properly. As working conditions and other factors vary, Bulwark Protection does not make any representation that these garments and personal protective equipment will protect wearers from injury. So that's out of the way, let's get on to the good stuff. As we said, common myths and misconceptions and misunderstanding. The top 10. When we're out in the field and we're talking to the folks that actually wear our shirts, pants, and coveralls as PPE, or as we like to say, we make life-saving pieces of equipment that just happen to look like shirts, pants, and coveralls, we get a lot of very similar questions. So we're going to go through these top 10 kind of one at a time. Some of these may pertain specifically to what you all do. Some of them may be from a contractor standpoint. Some may even be from away from the electrical side into the gas side. But hopefully something during our next 45 minutes here or so will resonate with you and your team. So fact or fiction, real easy. Is wearing these shirts and pants protecting you against arc flash and flash fire? Well, obviously, if the FR guy is asking this question, it's kind of one of those trick questions. So the easy one, arc flash, flash fire, is that's what this stuff protects against. The answer, no. The actual hazard is catching fire and continuing to burn. Arc flashes and flash fires, though they're serious and those thermal events can be catastrophic, if you do not catch fire and continue to burn, you're going to mitigate injury and take something that's potentially fatal and take that out of the equation. What do I mean by that? I can't injure enough of you in order for you to become a statistic if you are wearing good FR, wearing it properly, and you've taken care of it. Why? The only way to end up as a fatality is to have catastrophic body burn. Greater than 20, 30, 40, 50%. The only way to have that happen in these events is to catch fire and continue to burn. Think about it. A 6-cycle arc flash is an eternity for the person who happens to be unfortunately caught in that. But 6 cycles is only 1/10 of a second. That event is over. That ignition source is gone. If you are self-extinguishing and have put yourself out and are no longer being injured, we take fatality completely out of the picture. If you are unfortunate enough to be wearing fuel, aka cotton or polycotton, and you catch fire, now you have extended that 6-cycle event, that 1/10 of a second, to 30 seconds, 45, 60, or until all that fuel is burned off and the corresponding injury leads to fatality. So remember, the actual hazard you're protecting against is clothing condition, removing fuel from the ignition source. One of the other things we always get is this stuff is too hot. So the real question is FR/AR clothing going to cause heat stress? Fact or fiction? It's fiction. Single layer flame resistant arc rated clothing is no greater risk than single layer non-FR clothing. How do we know that? Real simple. We look at the American Conference of Governmental Industrial Hygienists and we look at their threshold limit values for heat stress and strain. They actually have a clothing correction table in that document. And when you look at that, when you look at work clothing, long sleeves and pants, and when you look at coveralls, the wet bulb glove adjustment correction factor for that, how much do you add to the heat index, is 0. There is no adjustment for single layer work clothing. So as you look at that, what does that mean? That means there's no additional threat of being vulnerable to heat illness wearing single layer work clothing, regardless if it has FR properties or not. Now, that all being said, the caveat is you have to understand that once we go into layering, once you go into arc flash suits, once you go into, for example, inclement weather, you can still have rainstorms when it's 60, 70, 80 degrees outside and now you're putting your rain gear on. Even as simple on a hot day as trapping your body heat by wearing a arc-rated vest. You now need to consider that heat illness may be prevalent and you have to adopt the most common mitigators of that via OSHA is hydrate, shade, and rest. And when you look at all the indicators in mitigating heat stress, clothing comes down very low on the table when it's single layer. Just remember that once you get into layering though, everything I just said prior to this is no longer relevant. You have to be careful though of not inadvertently reinforcing this myth. How does that happen? Well, think about it this way. Your team says it's too hot, it's heavy, it's uncomfortable, it doesn't fit well. So then safety responds with, well, you're the experts, just put it on when you need it. What does that do? That now accentuates the 3 things that we just talked about. You're going to go to work in cotton jeans, maybe even just a cotton t-shirt. Then you're going to put on your flame resistant arc rated PPE to do the corresponding hot task. So now you're donning a 7-ounce or a 9-ounce coverall over top of that, over top of your work clothing. You're adding additional layers, it becomes more cumbersome. And then also when you're looking at wearing and adopting something like a coverall, it's not form-fitting, it's not as ergonomically moves with you as a shirt and pant does. So you have just inadvertently reinforced, yet yes, it's going to be too hot because you're wearing multiple layers. It's going to be heavy and uncomfortable because again, you've got multiple layers. And third, it doesn't fit well because it's a coverall. So you're reinforcing the top 3 problems that already feed back into this myth. So how do you counter that? Look to lightweight, and this is the key, air permeable, moisture wicking daily wear. When we look at countering this myth, we get very little pushback from the waist down. Why? You're comfortable throughout, really since you were a kid, wearing dungarees, wearing denim. Denim is 12 to 14 ounces already in the non-FR world, so you don't get any pushback from there. We get pushback from the waist up. So look for garments that complement your evaporatory cooling system. They're going to be light in weight, they're going to allow air to pass through, and they're going to pull moisture away from your body. So just some key things to look at there. So as I say that, notice I said lightweight, moisture management, and I said moisture wicking, because lighter FR garments in and of themselves, are they more comfortable? Well, again, we're looking at fiction. Why? Because weight in and of itself is not a key indicator of comfort. And if you kind of want an example of that, next time you get your team together, next time you have a team function, whether it's during business hours, after business hours, just cast your eyes across the room. You'll see your team members in a variety of garments depending on the ambient air temperature and the conditions of that particular day. You might find some just in t-shirts, t-shirt and a sweatshirt, a hoodie, a long sleeve polo, a short sleeve polo, lightweight jackets, and all of them in that environment are going to be comfortable for their level of comfort. So why do we want to be conscious of just making decisions on lightweight? Lightweight in and of itself, okay, is not an indicator that it's going to be comfortable. That is a marketing brochure. So look beyond the brochure, because in many cases, in order to protect you, and remember, we are first and foremost a protective garment. To be under 5 ounces or to be very, very low in fabric weight, that weave has to be very, very tight in order to protect you against the thermal energy that's coming at you. So in order to do that, there's going to be no room for air permeability. The only way in those typical areas to have the protective value and the lightweight is I have to be very, very synthetic. So there's not going to be any natural moisture management there because there's nothing to pull. So I have to add a finish. And remember, all industrial wicking finishes last about 25 launderings. So in a very, very short period of time, you're going to have a lightweight, fully synthetic garment that is not going to be able to pull moisture anymore. So just be cautious and look beyond the brochure. Next big thing is obviously, in order to build this stuff, it's not inexpensive. These garments cost a lot of money. A shirt and pant in many cases is well over $200 today. You outfit a new employee, depending on how extensive you get with your program, you can easily be $800, $1,000, $1,200 in new gear per employee. So the fact that this stuff is so expensive, what does that really mean? Well, you've got to be cautious in evaluating this type of PPE exclusively on cost. If you move that decision-making process out of safety and into, say, procurement, and they're evaluating it on cost alone, you've taken safety out of the process. The whole reason of being in these garments now becomes a cost condition. Low cost. Obviously, like anything else, you're not going to get the quality or the durability. The replacement cost, I might be able to find something marginally less expensive, but if I have to replace it 2 or 3 times as compared to the original garment, am I really saving anything? And then lastly, as you look through those 5 points, the key area is, what are you communicating to your team? If you're purchasing solely on price, what are you telling the frontline employees as far as their value goes? And then lastly, if you think about it, if company X can produce a shirt, pant, or coverall for Y, and company Z can produce it for significantly less, where have they cut corners? When are you going to find out where those corners are cut? The day you don't want to find out where those corners are cut. Because if there is a way to build a garment that requires a certain amount of investment on the manufacturer and someone does it for significantly less, what corners have they cut? When you're talking about a life-saving piece of equipment, do you want to be relying on the lowest cost provider? An analogy I like to use is think of a fall harness. You're dangling 20 feet above the ground. You've just dropped 15 to 18 feet. Do you want to be relying on the least or the lowest economical fall harness to save your life in that situation? And the easy answer is no. You don't want to rely on something that's cut corners when you're hanging 20 feet off the ground. Just like in an arc flash or a flash fire, do you want to rely on something that's going to fail you and cause more body burn than is necessary if you had invested a little bit more? That leads into too expensive compared to what? Obviously, we're talking about body burn. Body burn arguably is the second most costly procedures in a medical facility. When you have greater than 40% to 50% body burn, you're going to spend anywhere from 60 to 90 days in a burn unit at a cost of $25,000 a day. When we see those kind of injuries and we see those kinds of costs, when you factor that in, just to get yourself out of the burn unit is going to be $1 million. The lifetime cost with that type of significant injury can be well into the multi-millions, $4, $5, $10 million of ongoing costs. So when you're looking and investing in a $100 shirt and $100 pants, that's where we ask, too expensive compared to what? Knocking body burn down from third degree to second, second to first, and first to zero, the more I can mitigate that, the more I can take that from 40 down to 30, down to 20, down to 10, significantly impacts not just the cost, but also the personal cost, also that ripple effect through your employee, your employee's teammates, all the way down to their relatives and significant others. Last piece we get all the time is this stuff just doesn't work. I go, this is something that's been perpetuated. Bottom line is, look at the graph. And this is an interesting graph because it's been used and it's been very, very similar, and those columns really haven't moved over the decades that I've been involved in this industry. And a lot of folks will use this to say, look, as we get older, we're less resilient to injury and we're more likely to succumb to those injuries. And yes, that is true. But how I like to use this graph is focus on that green column. That green column is significant. That green column represents 25% body burn. What that green column tells us is regardless of age, if I can get you to the right facility in a reasonable period of time, our folks are so good that you will survive almost 100% of the time. Let me state that a little bit differently. I am going to hurt 1/4, 25% of your body with significant thermal energy. And if I get you to the right place in a reasonable period of time, you will survive. So if you think about it, if you're interfacing a flame-resistant arc-rated pant, flame-resistant arc-rated shirt, you have buttoned it up to the neck, secured it to the wrist, hard hat, safety glasses, hearing protection, rubbers, leathers as an electrician, is there 25% of me showing? Can I injure 25? No, it's significantly less. That's how we can categorically say if you're wearing good stuff and you've taken care of it and you're wearing it correctly, 100% of the time there will be no fatality because there's not enough of you to hurt in these types of situations. Once I get this stuff, I'm bulletproof. I'm Superman. It doesn't matter what I wear underneath my FRCs, I'm going to be good to go. And the reality is, obviously, that's fiction. Any garment, first and foremost, in a chance of a short duration thermal hazard, has to be flame resistant and or arc rated. That includes your rainwear, that includes your vests, that includes your winter jackets, your hoodies, anything that you think of that's going to be the outermost layer. First and foremost, that has to be able to protect you in the hazard that you are looking to experience. Any garment worn as a base layer has to not contain meltable fibers. Well, we're all aware of the acetates, the polyesters, any synthetic fibers in there that are not part of that FR equation. They're going to melt, drip, and potentially add to the injury. So what is the default? Only natural fibers or nothing. So wear my shirt, nothing underneath. Wear my shirt, the most common is 100% cotton. Wear my shirt during the colder months, we've got wool, and also silk is a natural fiber, which is also acceptable. And all of those, as long as that outermost layer stays intact, will not melt, drip, and add to the injury, and that's why they're allowed by all our standards. The problem is, how do we as safety professionals know what our employees are actually bringing to work in this environment by just looking at the V at their neck? Let's assume for this discussion point, all my employees are wearing white t-shirts, and I see white V's across my entire team. Do I know 100% categorically that they have not introduced meltables into our environment? Can you get 50-50? Can you get 60-40? Can you get 75-25? Can you get any other ratio of synthetic and cotton white t-shirt? Of course you can. So how do I know as a safety professional, other than my training, that they have brought no meltables into this environment? Secondly, how do I know what sits just underneath the surface in meltable inks, that giant logo that's sitting on their chest that I can't see? So who's going to police the underwear in your facility? Who's going to go around and check off that every single one of your team members is wearing non-meltable 100% cotton undergarments? The reality is no one. So if that's the case, then do you understand that fundamentally you cannot say that you have not introduced meltables into the work environment? The other thing we've got to be cautious of, especially in our electric environment, is that break open is very real. And what is that? There are two ways to get an arc rating, an ATPV and an E sub BT. Every fabric has both. We just happen to communicate the lowest calorie rating for per the standards. So when I tell you this has an ATPV of 8.2, what's its E sub BT? You don't know. Now I know on my records because I've tested it to it, but you don't. If this has a break open, an EBT, then I know where it's going to break open at. What's my point? If I introduce more incident energy than this can insulate and protect against, it's going to fail. The picture of that shirt that you see in there worked perfectly. There's just too much incident energy for the arc rating of that garment, and you're starting to see failure. But technically, it did not ignite and continue to burn after the ignition source was removed, so that's a flame-resistant arc-rated garment. The concern there, obviously, is when you have break open is what am I wearing underneath? Even if I'm wearing 100% cotton, I've now opened up my protective layer and I've now introduced the incident energy to potential fuel. Could I have ignition underneath my arc-rated garment? The chance is there. The picture below indicates the wrong fabric to be wearing underneath our flame-resistant arc-rated clothing. Going back to our original question, it's too hot, it's uncomfortable. What can we wear outside of work that helps mitigate heat conditions? I'm sweating, I'm uncomfortable. Garments that cool us down and move moisture, 100% synthetic. We call them performance fabrics today. That is what a performance fabric looks like after an arc flash. The outer layer, which was arc rated, worked perfectly. All that thermal energy passed through the fabric, hit that lightweight 100% meltable, liquefied it, then drove it into that young electrician's skin at 2,200 square foot-pounds of energy. Those scars he will carry forever for failure to what? Wear the proper undergarments. How do we eliminate that? We eliminate that by going to an arc-rated base layer. Regardless of the manufacturers today, you'll see that little logo right there at the neck. That logo identifies to our safety folks that my team's indeed protecting themselves all the way through. If it says FR, that's all I need. Why is this cautionary? Well, because there are items within our arsenal that are being marketed to our utilities, to our electrical contractors, to our refineries, our oil and gas, and our gas utilities that claim to be flame resistant, but are only tested to one standard, and it's not a performance standard. Standalone standards in and of themselves are not an indicator of FR properties for what we do. For example, did you know that rain gear has their own standards? And it's not an NFPA standard, it's actually an ASTM standard. 1891 for arc flash and 2733 for flash fire. And yes, you can get both in the same rain gear. I want you today, if you are listening to this, to take note of this section and go check your rain gear and your safety vests and make sure that they are beyond FR. How can you identify that in the field? Well, here's a simple example. This is vests and rain gears that's marketed into our utilities, our refineries, and our gas utilities all the time. This states that it meets the FR requirements by meeting ASTM 6413, which is the vertical flame test. You'll notice if you read this label all the way through, it contradicts itself numerous times. It tells you it's non-FR per ANSI, and we'll talk about that in a second. Then it'll also tell you it's FR because it self-extinguishes. And then if you read it all the way through, the self-extinguishing properties will diminish with washing. That's literally, if this was rain gear you can't get wet. If this is the type of vests and rain gear that you have on your facility, you have the wrong rain gear and the wrong vests. The other easy way to look at it is go down to purchasing, go talk to your procurement agent and ask them what did they pay for their vests and what did they pay for their rain gear, because in many times we find that in our utilities the employee gets to choose their shirts and pants in many cases. The employee gets to use their allowance for shirts, pants, jackets, etc. But the company buys rain gear and buys vests. And that decision goes where? Out of safety and into procurement. And why do I say that? If you've paid $120, $130 for your set of rain gear, that's a jacket and that's pants, you've all got the wrong rain gear. You're going to be paying closer to $400 to $500 for the right rain gear that will perform in your hazard. Because remember, ASTM 6413 is not a performance test. It is one of the preliminary tests that we build upon in order to get you that ARC rating or get you to that 2112 compliance or get you to ASTM 2733 or 1891. How can you go and check? ANSI's done a great job of communicating what the 6 standards that are acceptable in order to market as flame resistant. If none of those standards are met, then the garment has to tell you that it is not flame resistant. And you'll notice that ASTM 6413 is not one of the applicable standards. So there's a place to go and reference right away. For our gas utilities, flash fire as opposed to arc flash, different test methodology. In fact, the big test that everybody likes to see is ASTM 1930, which is our mannequin test. It's four burners with 2 per each, so 8 burners, 365 degrees of exposure, total of 3-second burn, and we test our fabric to whether it can produce 50% or less body burn, and then additional testing may or may not allow us to start building garments out of that. So it's important to understand what that test methodology actually is. First and foremost, it's single layer fabric. Secondly, it's an indicator for us to evaluate fabric so that we can still start building garments for this hazard. In fact, if you are in the 2112 standard, which is for manufacturers and how to build garments to protect against this hazard, it will tell you cautionarily, do not use the ASTM 1930 test data for your requirements to purchase. This is not for procurement. This is a performance standard to evaluate fabric. These are not commercially viable garments. Why is that important? It's important to understand the difference between a laboratory, where I have my 8 burners, I have my 360 degrees exposure, I have my full 3 seconds of exposure, then I collect data for 60 seconds on the mannequin. Versus a real world rapid moving flame front, which is the flash fire hazard on our facilities. So you'll notice here we have a facility, we have propane, and we have an ignition source that we have highlighted. Within the 22/100ths of a second of touching that ignition source, you can already see the flame front is starting to advance back to the source. Within this 40 feet that you see in this clip, we have already moved about a quarter of that away from the ignition source. As that continues on, we're looking at roughly, what, 1.8 seconds and change afterwards. It's already cleared the whole apparatus and it's back at the ignition source, and you see that that area is no longer any thermal energy. Why do we have that? What we want to show here is picture any point in time on those frames, and if I was to put a mannequin in a coverall, at any time is it 360 degrees exposure? At any time is it a full 3 seconds of engulfment? The whole event in that whole 40 feet is not even 3 seconds. When that rapid flame front is rushing back to the fuel source, at no time and point in time does it cover it for 3 seconds. So why do we emphasize that? Because the test data that comes from the actual laboratory is significant in the fact that it is absolutely potentially worst case scenario versus what's happening on your facility floor. I say that, and then lastly I'll just caution. If your hazard is greater than 3 seconds, aka I'm in a gas utility and I'm actually digging in well holes and I'm working in well holes, completely changes the hazard assessment. No longer am I able to egress to safety, and that's what the 3 seconds and the 2112 requirement requires. That in 2113 I have to be able to egress to safety. I have to be able to move away from the hazard. Can you do that in a well hole? No. In fact, the American Gas Association has determined it anywhere from 6 to 8 seconds for my employee to recognize the hazard and get out. So I need to look at multiple layers, I need to look at extraction suits, I need to look at a whole different response to my hazard assessment. Lastly, and thankfully this was probably in the last, well, we're going on a decade now of 1910-269 changing, where in 2014 we stated that you need to have flame-resistant arc-rated clothing reasonable to an estimation of the incident energy that you're exposed to. Prior to that, cotton was acceptable. We still see some lingering in there that cotton's good enough for electrical work. Thankfully, it's worked its way out, but the reason we don't want to do this is obviously the law says you can't do it. If you're on the general industry side, the nationally recognized consensus standard NFPA 70E says you can't do it. So why can't you do it? That's what fuel looks like in front of an ignition source. We had a small arc. By small, you can see the 4.1 calories per centimeter squared is the incident energy that came out of that box that instantaneously ignited that 100% cotton t-shirt, aka fuel, on that mannequin representing our electrician. The other thing that reasonable estimate tells our electrical workers is what? How big a bomb they're standing in front of. I would like to know, is it a firecracker or is it 4 sticks of dynamite? Am I in my bucket, in my T&D lines, which are typically 5 calories or less, and I can wear my 8-calorie shirt and my 12-calorie jeans, my rubbers, my leathers, my hard hat, my hearing protection, my eye protection, and I'm good to go? Or am I in a substation where I've got potentially 32 calories of incident energy on the breaker that I'm manipulating or working, or what other electrical equipment we may have? Because I'm going to dress differently. That's why we have 40-calorie suits available on our substations, but we're not putting our linemen in 40-calorie suits to go up in a bucket, because we know what the hazard assessment is. The other thing that we've seen, especially in general industry, and we've seen, in some substations, is flame-resistant arc-rated lab coats are not PPE for our hazards. In fact, if you read the definition of the garment, it says lab coats. That's the only place that these garments should be utilized. 70E, for example, spells out long sleeve shirt, pants, and or coveralls, regardless of the incident energy you're looking at. There is, yes, it has long sleeves, but it does not secure up to the neck. There's too big of a wide neck opening. And lastly, everything below here is going to be exposed for the arc to hit the ground and come up underneath, and also for potential fuel being worn from the waist down. We do not want to see lab coats as any way to either as a primary protector or even supplementally used. And we definitely don't even want to use it as a guest option to where you need to be in flame-resistant arc-rated clothing moving through the facility. So I come in my business suit, I take off my jacket, and now you're going to give me a tour and you're going to put this on me? Definitely a no-go. Speccing inherent FR as it is better than treated FR. Fact or fiction? Well, 30 years ago, you might have had some talking points because 30 plus years ago we had Nomex and we had FR cottons. Nomex was used in oil and gas in our refineries, and FR cottons were used in our steel mills. FR cottons back in those days were treated in the true intent of the word. It was a topical treatment. It lasted between 25 and 50 launderings, and it was primarily used in our foundries and in our steel mills, and their main protection was against heat and potential. They didn't care. They wore the garments out long before the FR properties wore out, so it did not matter. These terms became obsolete really in the late 80s, early 90s when we had the first durable FR cottons, and now we actually had competition between quote unquote our inherent synthetic world and our cotton quote unquote treated world. So the common misunderstandings of the terms as they were exposed back then was primarily marketing. What we had was a dominant FR solution in the marketplace that was now being threatened by this new FR solution. So the terms inherent was to imply doubt between one solution versus the other. Because if you think about it, inherency means that it is in and of itself flame resistant, when in actuality everything has been developed other than asbestos to have FR properties. When we look at fibers like Nomex, FR nylon, we tweaked the chemical properties, the molecular formula for nylon to where it became unable to support combustion. We take a modacrylic, a modified acrylic fiber, and we add FR chemistry when it's a soup, and we extrude a fiber now that has FR properties. We take a fabric like cotton, aka fuel, and we run it through a process where we bond chemistry to it like nitrogen and phosphorus where it can't support combustion. All of those are man-made solutions, so how can they be inherent? So the point is these terms were utilized to imply some kind of doubt. And they really are obsolete today. When you look at your solutions that are available on the marketplace, when you are evaluating solutions, you'll see combinations, 48% modacrylic, 33% lyocell. The remainder will be some kind of aramid or para-aramid. Is that inherent or treated? If I have non-FR fibers running east and west and FR fibers running north and south, regardless how I've got there and regardless of their percentage, is that garment inherited or treated? Really, it can be both. There are no rules for us to market that to you as my end users. What you really need to understand is there's three ways that are commonly practiced in order to provide you a flame-resistant arc-rated solution. I can change the molecular formula of a synthetic and it will not support combustion. I can add FR chemistry at the fiber level when it's still a soup and extrude an FR fiber. At the fabric level, I can introduce chemistry that will bond to that cellulosic for the life of that garment to where it will not support combustion through charring. What you want to know is you're either going to have one, two, or potentially all three of these solutions in your fabric today. What you really want to pay attention to is the guarantee from the manufacturer. Does that manufacturer support this solution from inception till retirement, meaning will it be FR for the life of that garment? That's the only requirement that you want to see in the guarantee. You don't want to see guarantees to meet the standards. You don't want to see guarantees tested to the standard. Why? Standards are very, very minimal. For example, ASTM 1506, 25 laundries, we tested. What at 26, 27, 28? Well, if you only say it meets the standard, you are out of guarantee at 26, 27, and 28. You want to see that manufacturer supporting that from inception till retirement. This is kind of more to my electrical contractor community. Think of this way. I'll just get everyone a hot kit and that way they'll be safe. Kind of the difference between being compliant and safe. If I check my list that all my electricians have their hot kit, in that hot kit I've got them an arc-rated coverall. I've got them their rubbers, their leathers, their hard hat, their face shields, balaclava, hearing protection, eye protection, their insulated tools, and that kit is outfitted to every one of my electricians that's going to do energized work during the day. What's the downside of that? Well, really the downside is compliance is not necessarily safe. Compliance is a checklist. There's a broad spectrum between outfitting your team with the proper solution, training them on how and when to use it, and then sight unseen them actually using it. Task-based programs for this type of PPE has huge pitfalls. And what do I mean by that? Well, are they going to wear it when you're not looking? And then secondly, from the investment standpoint, it doesn't make any kind of sense. How can I exemplify that for you? Think about, just let's run the numbers. Let's say I own an electrical contracting firm. I have 10 electricians that do energized work every single day. Those are my service techs. They're out with customers. They're doing energized work per the 70E standard, for example, which is troubleshooting, verifying, and voltage testing. So my 10 guys do 10 energized tasks a day just to make it easy. That's 100 tasks a day over 30 days. That's 3,000 energized tasks a month. Over the course of a year, that's roughly 30,000 opportunities for them to get in and out of that PPE or not to get in and out of that PPE. That's 30,000 opportunities as you as a business owner where your team may fail to wear their PPE. That's one aspect of it. The other aspect of it is the cost. Think about 10 stoppages to change in and out of their PPE every day. What's that cost in time? 5 minutes to get in, 5 minutes to get out, times 10 times 10. And I'm just going to even use a conservative number of around $20. That's about $10,000 a month in soft costs or lost time to this task every single month for you as a business owner. Where if you implemented daily wear, a baseline of protection twofold. First and foremost, I know I've got a baseline of protection. Even if I choose not to use any of my other PPE for whatever reason, even if I choose to go up and voltage test a 200 amp disconnect with no rubbers, no leathers, no hard hat, no face shield, no balaclava, and I insert my leads into that and it arcs for whatever reason, I've not caught fire and I've not continued to burn. I've mitigated my injury. Now, I'm going to damage these. I could potentially be damaging this, but those injuries will not be life-threatening. The other side of that is going back into your costs. I'm not now spending 10 minutes, 10 times a day, times 10 employees getting in and out of my PPE. I'm simply slipping on my rubbers and leathers, my hard hat, my balaclava, my safety glasses, my hearing protection, etc. And I go and conduct whatever energized task I have. So if you take that to where it's going to cost $1,000 a year per employee to outfit them in an arc-rated shirt, pant, and or coverall, and a corresponding jacket or what other peripheral gear you may need, that equates to about 42 cents an hour, about $35 a day for your team of electricians, which is a fraction of what it would cost for you to implement the task program when you look at all that lost time activity. As we wrap up, I want to thank you all for your time. I want to thank Brent and ECOS for us coming out here, and I want you to remember one last thing. Yes, when you look at the hierarchy of controls, when you look at substituting and eliminating and looking at your admin controls and engineering it out, and you go all the way down through the pyramid. Absolutely, PPE is the last line of defense, and everybody will tell you it's the least effective. But if you have an arc flash incident, if you have an arcing fault, or you have a flash fire, all those other controls are gone. There is no opportunity to go back in time. There's no opportunity to go and do something different. Your last line of defense is that shirt and pant that you are wearing that day. Was it good to begin with? Did you utilize a proven supply chain partner? Do those garments have a pedigree of success in the hazard? Are they designed and tested for your hazard? Have you taken care of them properly? And lastly, are you deploying them correctly? Are you interfacing them to give you the best outcome in that thermal event? Because it's happening. And just like your safety belt's that last line of defense in a head-on collision of whether you're on this side of the windshield or 25 feet down that highway. And ask any highway patrol officer survivability of ejection accidents. Even with all that engineering that we have around in our new automobiles, that safety belt only works if you click it. And think about it. How many times have you clicked that safety belt from the time you were 15 to hopefully 75 when you retire from the highway? How many times have you clicked it and not used it for what it's intended for? How many times are you going to wear this stuff properly and not use it for what it's intended for? But if you have to, just like that safety belt, you have to be wearing it correctly, and you have to be wearing it when you need it. So yes, it is your last line of defense, and yes, it is the least effective, but it's all you've got in an arcing fault or a flash fire. So with that, I thank you again. Normally we'd have questions and discussions, but if you do want to participate in that, that is my email. Take a screenshot of this, save that, and feel free to contact me at any time. And with that, I thank you all for your time.